All right, this is chemistry lesson 8.07 on double displacement reactions. And today we are going to look at the reaction of strontium chloride plus sodium sulfate. So let's go to this video clip, and it's a short one today. It's the only one I could find. Come on, there we go. So we have in the beaker an aqueous solution, and we're adding to that another aqueous solution. And you can see they're both clear. So as this gets poured in, this is clear and this is clear. So watch what happens here. Okay, so let me stop sharing here. All right, you could see that it turned white and cloudy. So we definitely had some kind of a chemical reaction. Well, let's look at this in a little more detail. So we need to start off with formulas. Remember, one of the rules is having correct formulas. So if we look at strontium, strontium is +2 and chloride is -1. So this is a metal and a non-metal. So we're going to have ionic compounds. Sodium is +1 and sulfate is -2. This is one of the steps that students start to skip after a while. And a lot of times when they have formula errors, I'll say, did you write out your ions? They're like, no, I didn't do that. Since this is +2, we're going to have two of these. So I'm going to have SrCl2. And this was aqueous. And to that, I'm going to add sodium's +1, so I need two of these, and Na2SO4. So double displacement reactions, we said back at the overview video, are, let's see, I think these were green, right? AX plus BY is going to give us AY plus BX. So you could say the cations swap their anions, or the anions swap their cations, however you want to phrase that. So what we're going to have happen here, we're going to have a flip. And we're going to end up with strontium sulfate and sodium chloride. Plus sodium chloride. Well, strontium's +2, sulfate is -2, sodium is +1, chloride is -1. So here I'm going to have SrSO4 plus NaCl. All right, I'm not balanced. And I'm not going to write out, at this point you're balancing, you should be able to get it a little bit faster. So right away you see that sodium, we've got 2 of those and we've got 2 chlorine. So putting a 2 there is going to balance the equation. But what we're missing is, oops, and I also forgot to put that this was aqueous. So we had the solution turned white. And in class, when we do this demonstration, when the students look at it, they can tell that there's bits of stuff floating in the solution. Now, you guys have seen what happens to salt when you put it in water. It doesn't stay together. Table salt, NaCl, likes to dissolve in water. So the chances of the table salt floating around in little bits, not very likely. In fact, the table salt is, NaCl is aqueous. So that means that here, the strontium sulfate was my white chunky stuff, and I need to put a solid behind that. So we talked at the beginning of the chapter, how do we know a chemical reaction takes place? When we mix two aqueous solutions together and get a solid, we call that a precipitate. And in the lab for this packet, you'll be a couple of the stations, or at least one, you'll be making a precipitate. So when you mix together two things that look perfectly clear, and all of a sudden, boom, you get a solid. So double displacement, all we're going to do is we're going to swap. So I have a practice one down here. And that's a capital I. It doesn't look like, I don't think this font, the capital I's, look much like I's. Before I have you guys do this one for practice though, let's look at this. This is special because what I have here, HNO3, is an acid. And any hydroxide that you see is a base. When you add an acid and a base, you get a special kind of double displacement reaction called neutralization. So we're going to look at this neutralization. You should be able to recognize bases by the presence of hydroxides, but how do you know acids? Well, here's the thing. We're going to hopefully at the end of the year get in a chapter on acids and bases, but until then, I'm going to give you a list of acids to memorize. So you're going to memorize HCl, HNO3. You're going to do H2SO4. What else? H3PO4. And oh yeah, CH3COOH. Or we could write this as C2H4O2. C2, yeah. So either way, you could write these. It's the same thing. And you'll see it both ways. The first one is hydrochloric acid. HYDROCHLORIC, hydrochloric acid. Second one is nitric acid. Nitrate becomes nitric. Sulfate becomes sulfuric. Phosphate becomes phosphoric. And this is acetic acid. If you remember acetate, we write acetate as CH3COO -1. So this is the acetate ion. Or C2H3O2. Different websites will write this out differently. So sometimes they'll put the hydrogen at the end and sometimes they'll incorporate it. But I prefer this because that's how you memorize the ion. So I'll always use this. The only reason I add this is because that's what some websites use. And you just have to memorize these. You have to know these for the test. Okay. What's going to happen here in acids? Hydrogen is my cation and my nitrate is my anion. So this is my cation and this is my anion. When you know that, then hopefully you can see what's going to happen. You're going to get a switch. Let me change colors. Let's go to orange. So when we do a swap, we're going to have this. The hydroxide and the nitrate are going to switch. So this is going to give me HOH. Lithium is +1 and nitrate is +1. So it's just going to be LiNO3. And I'm balanced. So do you recognize this? Is there another way to write this? HOH, isn't this the same thing as H2O? Yep. So when you combine an acid and a base, you get this compound, and this is, by the way, we'll get to this in the acid-base chapter, is called a salt. We have a salt plus water. Okay, so for practice, go ahead and try potassium iodide plus lead Let's see what's that going to be. Lead 2 nitrate. Okay. All right, welcome back. Let's see how you did. So what we're going to do here is we're going to swap our anions. The iodide and the nitrate are going to swap. So I'm going to have, and let's go ahead. I'm going to kind of come. I always go somewhere off to the side when I write out ions and their charges because I don't want those to end up in my equations. So I'm going to kind of come out here. Potassium is +1 and iodine is -1. Nitrate is -1. And remember our rules. If I have 2 of these, I have a -2 charge. That means I have lead +2. You have to always remember with type 2 cations, which one do you have? And that's what earlier in the chapter I said, you can't forget all of your rules about naming. All right, so when I go to swap, I'm going to have, these guys are going to swap, and I'm going to end up with potassium nitrate and lead 2 iodide. So potassium is +1 and nitrate is -1. So I'm going to have KNO3. I'm not going to worry about states of matter here, probably aqueous. Lead is +2, so I have to be PbI2. I have to have 2 iodines to level out that lead. So I have 2 iodine on this side, and I have 1 over here. So to balance, color, I need to put a 2 here. And I've got 2 nitrate, and I've got so I have 2 iodine here, so I've got 2 iodine here. I have 2 potassium, so that means I need to bring a 2 over here. So let's check our math here. I've got 2 potassium, 2 potassium, 2 iodine, 2 iodine, 1 lead, 1 lead, 2 nitrate, 2 nitrate, and I'm balanced. All right, I hope you got that right. And we're going to do combustion to finish up our categories. That's it for double displacement.